Hello world, Kyle here with NimbleNoggin.io, and today we're going to talk about some special breakpoints. So I have three in mind that we're going to talk about, and these are three that I typically keep in this breakpoint bank over here. So we are going to add them to this project since they do come in handy in the situations that you would use them in. So we're going to add them here and talk about how to use them and why I like them. So the first one we're going to add is an exception breakpoint. So we can go down here under the breakpoints navigator to this little plus button down here, and we get a little action menu, and we will choose add exception breakpoint. And right now it is set for all exceptions, and you can right click and edit it and work on tweak some stuff, okay? But it's easiest for me, and I've always just kept it normal vanilla all exceptions breakpoint. So I'm actually going to add a crash into the app, and the crash that I'm going to add is we're just going to nslog an element that does not exist in this waiting strings array. So since there are 4 elements, we can actually print to the log waiting strings object at index 4, since index 4 would actually be the 5th element in the array. It's not there, so the app will crash. But what's cool about exception breakpoints is if the app crashes due to an exception, not because it ran out of memory or a broken reference to something. For an exception crash, which is normally what logic crashes that you run into are. So I'm going to open this view controller, and we put it into the method text field did change. So let's just click on a text field and edit that, and the app will get to this line, it will run this line, it will throw the exception, and before the app crashes, it will put this little red breakpoint indicator here with the crash in this description to the right to tell us what was happening. And we can maybe see what was going on at that point in time in the scope of the crash to maybe find out what caused it. So we can see anything that was printed to the log, and this was not printed to the log because that's what crashed. And we can look at some current values and just the general what was going on in this class and in this method that made it crash. And we know that it was actually none of this stuff, it's just this line that I put here. So we can continue program execution over that, and sometimes you'll maybe get some more debug log output or something, but just because this is a crash that we put, there's not much to it, and it's kind of obvious, we can just get rid of that. But the breakpoint did point right to this line where the app did throw an exception, which is awesome and very useful. And I just did some weird backspacing, so I'm just going to fix that up and stop the app. And let's talk about the next breakpoint. And I'm going to keep this one here, and I'm going to keep it active just in case we would maybe run into an exception later. I don't think we will, but it's nice to have. This next breakpoint is called a symbolic breakpoint, and how these work is, so sometimes when an error or warning is thrown during the runtime of your app, they actually have these symbols that are available that a symbolic breakpoint can catch. And you can see here that the example is on NSException, so we could add an exception breakpoint custom with the symbolic breakpoint input, but since I guess the exception breakpoint is popular and useful by itself, that it has its own little, exception breakpoint menu or item in that action menu. So I'm going to get rid of this, and we're going to go to the situation where I like to use the symbolic breakpoint, and that is when dealing with auto layout. So I'm going to open up the gestures view controller, where we have a lot of UI gesture recognizers that are going to be working with auto layout constraints to interact with this blue square in the center of the screen. And something that I haven't gotten around to fixing with the Swift Component Store app yet is that this screen has a lot of constraint conflicts, and they're not bad because none of them actually make the app crash, and it still behaves how you would expect it. We just get gobs and gobs of debug log output from that. So we can see here at the bottom of the output it tells us that we can make a symbolic breakpoint at this symbol, and I'm going to copy that with Command C to catch this in the debugger. So what is cool and awesome about these symbolic breakpoints is I'm going to create one. I'm going to copy that symbol into there and not worry about any of the other items in that, and just run the app again, so that when we do open this screen and we perform one of the gestures, it's going to throw that constraint conflict warning back into the debug log again. So I'm just going to move this, and before it actually moves, we've hit a breakpoint. Now, this does not look very useful, but that's because we are actually in this file or realm, whatever's going on right here in this UI alert for unsatisfiable constraints something. It looks like a lot of pointless nothing. Maybe what you would do if you were a hacker in a movie. You could read this. But we can't, but we do see something familiar here, and that is a file that we created in IO Gestures View Controller. So I'm going to click on that is in a different place in this queue of the main thread. And we can see that this breakpoint has stopped at the line that is causing trouble, that's maybe causing this constraint conflict. So if I do take the time in the future to fix this, then I know that I can find it right here, instead of wondering, hey, I'm on the screen, look at all of this auto layout constraint stuff I'm doing, I have to go through each one and make sure they're perfect and figure it out in my head. No, we have the symbolic breakpoint on that unsatisfiable constraint symbol, so that we know the issue is right here, so we can continue program execution. And we have hit another. Let's go to the view controller, and we can see that it's hit a different part of the method. And before we were on this left constraint one, and now we're on this top constraint one, and they both are doing sort of a similar thing. So maybe this logic is causing an issue when we're adding a point in view.x or .y. So let's see how many there are. I'll continue program execution, and that looks like the only issue. And we can see that they've both printed their output to the log, and they're telling us that we can create that symbolic breakpoint here. But that's for another time. We're going to look at the final breakpoint, which is a test failure breakpoint. And we have not talked about any unit test stuff yet, so you'll just have to bear with me. But this is useful when you are running unit tests, and we can see that there is a tab in the test navigator, a tab in this navigation stuff up here called the test navigator. And here we see that both of our tests that we have two tests in this auto created file called Swift Components Tor tests. Both of these tests are just template stuff, so let's actually change one of them to fail. And then we can run the unit tests up here by holding click on this run debug stuff until the action menu pops up and select test. So we're going to build the test and run the test, and we should see, since we have our test failure breakpoint, that we're going to hit it on this test that would fail, so we know which test failed and where it failed, why it failed. We can see what's going on in the current test class right here. So if we continue program execution over that, it will go over this, and we will get a lot of visual cues that we had a test fail here. We see that this test class was marked as test failure, this method was marked as test failure, and the specific assert was marked as test failure. So since this assert failed, it says the method failed, and it says the whole class failed. And we can see that in the test navigator up here, but it was useful because we had this test failure breakpoint anyway. When you have some longer tests or some bigger tests, this can still be useful even though you have all these other visual indicators. So these are my 3 favorite breakpoints. That I'm not counting just standard breakpoints that you would throw in anywhere. These are my favorite special, unique, custom breakpoints. And typically how I use these is I keep the exception breakpoint on all the time. I deactivate the UI alert for unsatisfiable constraint symbolic breakpoint, and I deactivate the test failure breakpoint. And yes, there are cases where you would want to deactivate the exception breakpoint. Some libraries and frameworks sometimes do throw exceptions that don't crash the app, and some apps I've worked on, every time you launch the app, you're going to hit a couple exception breakpoints, and it's just annoying and easier to turn that off. And you can get even more custom with this and say, don't throw any exception breakpoints until after these other breakpoints have been run, so we can avoid any of those exceptions that might be coming from third-party systems. And the reason I keep this symbolic breakpoint off for unsatisfiable constraints is that during development, you're more worried about getting the feature done or fixing a bug than maybe if there's one constraint that's off. But it is useful to turn this on sometimes if you have a screen that is a little buggy or a little laggy. Fixing some of these constraint issues can clean that up and make it a little speedier and more responsive. And keeping the test failure breakpoint inactive, it's really up to you, and it only really matters when you're working in the unit test or running the unit test target or files. But as you're writing new unit tests, you're not going to expect them all to pass the first time. So once you get a good basis of unit tests going, and maybe after you have 50, 100, 300 or 400 unit tests, you can keep this on so that you do know when any of them fail, and you can just fix while you're running through the execution of the unit test target. So if we do run this, we are going to hit this first breakpoint. We can change that to true so that it does pass, or fix whatever's going wrong in the specific test that hit the test failure breakpoint, and skip ahead and just continue for any of the failing tests for that. And then when you rerun the test target, they should all pass as long as you fix them all, which is great. And I would really recommend all three of these breakpoints. There are more useful ones, and there's even an item down here that we didn't even cover, but it has to do with OpenGL, which is nothing even close to what we're doing in the Swift Component Store. So there you have it, special breakpoints, unique breakpoints. Thanks for watching.